Reference angles. So a reference angle is the shortest distance to the x-axis. Okay. Couple key phrases here. It's the shortest distance. Okay, so shortest means get to any x-axis you can as fast as you can. I use the word distance in math. When we talk about distance is always positive. So always positive. And we're always going back to the x-axis. Okay, so let's talk about some reference angles. So for example, if I said 205 degrees, okay? The x-axis starts at 0 degrees. Over on the left side is 180 degrees. And then back on the right side again would be 360 degrees, right? So I got to figure out where 205 degrees is. So if I go half a circle, that's 180. And then if I go a little bit more, I will get to 205 degrees, right? Okay, so to find the reference angle, I want to find the shortest distance to the x-axis. So I have two choices. I can either continue to the right side of the x-axis, or I can go back to the left side of the x-axis. Well, if you notice that green shading, that going back to the left side, that's a lot faster. So I want to find this distance from 180 to 205. So all I have to do is subtract them. 205 minus 180 gives me 25 degrees. So this distance from here to here is 25 degrees, and there's my reference angle. Okay. If we were at, let's say, 590 degrees, let's figure out where 590 degrees is. Okay, so a full circle, so if I go around one full time, that's 360, right? So when I subtract 360 from that, I still need to go another 230 degrees. Okay, so that's kind of where my focus is at. Okay, so let's remember, I need 230. So each quadrant is 90. That would be 90, that would be 180, that would be 270, and this would be another 360. Okay, so after a full circle, to get to 230 more, I would need 180 more, that's half a circle, and then it's not quite getting to 270, I only need to get to 230. So again, I end up somewhere in quadrant 3, that's 230 degrees. Okay, I want to find the shortest distance. Well, this angle is the shortest distance, it's much quicker. So to get from 230 back to 180, we'll take 50 degrees. And there is your reference angle. Now let's say, for example, I did 10 degrees. We'll give you a couple quick examples here. 10 degrees is only up 10 degrees, right? So we say, well, how far is that from the x-axis? Well, I'd have to go back 10 degrees to get there. So if I give you 10 degrees, that's okay, that my reference angle is 10 degrees. And we'll do one more before we go to radians. Let's say I give you 330 degrees. Okay. If I know my quadrants, that's 90, that's 180, that's 270, and this is 360. So 330 degrees would be somewhere in quadrant 4. If I'm at 330 degrees, I got two options. I can finish the circle and go to 360, or I can go back the way I came and go back to 180. In this case, the yellow is much smaller, it's much quicker. So how many degrees does it take to get from 330 all the way up to 360? And the answer is 30 degrees. There's your reference angle. Okay, now what happens if it's in radians? So reference angle in radians. Okay, now this actually works out really well. Okay, so if I'm looking at a unit circle here, if the x-axis, if I go to this side of the x-axis, that would be 1 pi. If I keep going and I go back and I do a full circle, that's 2 pi. If I keep going around again and I get back to this point again, that would be 3 pi. Keep going over here, that would make 4 pi. And 5 pi on the left, and 6 pi on the right. If I look at these, not only do I realize that everything on the left is odd and everything on the right is even, but more importantly, these are all whole numbers. That's 1, there's 2, there's 3, there's 4, there's 5, and 6. So to get back to the x-axis is like going to the whole number, the next whole number, or going back to the original whole number. So if I can give you guys something like 16 pi over 5. I still want to write these as a mixed number because that's going to make life really easy for me to understand. 5 goes into 16 3 times, okay, with 1 left over. So that would be 1 pi over 5. So now when I'm actually figuring this out on the graph, well, I don't know what happened there. I want to go 3 and 1/5 pi. Well, 3 pi is on the left side. It's way over here. So that would be 3. And then after I go 3, I go an extra 1/5 pi over here, right? And so my question becomes, what's easier? Is it easy to go back 1/5 pi? Right? That over here would be 1/5 pi. Or do I want to keep it going and go to the next x-axis and go to the next whole number? Well, to get to the next whole number, if this is 1/5 pi, I would need 4/5 pi to finish it off, right? So we just look at these two options and say which one's smaller, and the smaller one is the 1 pi over 5. So this reference angle for this one is 1 pi over 5. Okay, let's do another one so you guys can kind of see it a couple times. See if I can erase these things. Nope. Okay. What if I did, for example, 23 pi over 5? Okay, so 23 pi over 5, if I write it as a mixed number, 5 goes into 23 4 times, and there would be 3 pi over 5 left over. Okay, so on my unit circle, 4 pi is on the right side, 4 pi, and then I have to go an extra 3/5. Now, 3/5 is like 0.6 pi. This is bigger than a half. So what that tells me is I'm going to go more than one more quadrant. After I get to 4 pi, I have to go more than one more quadrant, and I'll finish up somewhere in quadrant 2. So from here to here, that's the 3/5 pi. If I want to finish the unit circle, if I want to go to the next x-axis, if I'm at 3/5 pi, I need another 2 pi over 5, 2 pi over 5 to finish that circle up. So my question to you is, which one's faster? Or which one will get me to the x-axis quicker? The 3 pi over 5 to go back, or the 2 pi over 5 to get to the next whole number? And for me, the faster route is to go to the next whole number at 2 pi over 5. Okay, we'll do one more. We'll do one more. Get these out of here. That worked better. Let's try a negative one. Negative 14 pi over 9. Okay, it is negative, so it's a little bit different. 9 goes into 14 once, with 5 pi over 9 left over. Okay, same concept, but we're just moving in the negative direction. So here, to get to -1, remember I'm moving in the clockwise direction, negative 1 pi would be over here at negative 1 pi. So that puts me on the left side. And then I have to go an extra 5 pi over 9. Well, 5 pi over 9 is bigger than a half. Like if you take 5 and double it, you get 10, right? So 5/9 is more than a half. So 5 pi over 9 would be from here a little bit more than one more quadrant. So from let's say from here to here would be 5 pi over 9. So to get back to the next x-axis or the next whole number, I would need an extra 4 pi over 9. And you just have to look at these. Which one of these is smaller? Well, 4 pi over 9 is smaller, so 4 pi over 9 is my reference angle. And that is how you do reference angles.